Welcome to Crosstalk Solutions. My name's Chris, and today we're going to teach you how to boot a Raspberry Pi, not from the microSD card, but from a connected USB 3 hard drive. It could be something like this SSD that I've got right here, or even something like an M.2, as you see in this little M.2 enclosure that I've got. Now, Raspberry Pis have been able to do this for a little while, but it used to be that you had to jump through a whole bunch of hoops to get it done. You had to put on some beta firmware or a beta bootloader to the Raspberry Pi to make this function, and that's no longer the case. But online, there's a lot of that old information still out there. So I wanted to kind of clear it up and create a definitive how-to for how to get your Raspberry Pi to boot from a USB 3 external source. And so that's what we're going to do in this video. And how do we get started, right? So the first thing you're going to need is a Raspberry Pi. I recommend the CanaKits. I have links to all of this stuff down below in the description. Those are Amazon affiliate links. If you click on those links, it doesn't change your price at all, but it does get us a couple bucks for the referral, and we certainly appreciate any referrals that we get. So I like the CanaKits. It comes with everything that you need, including the microSD card, which you're not going to keep in the Raspberry Pi, but we're going to need it for the initial setup of the operating system. And the Raspberry Pi 4 gig CanaKit, Raspberry Pi 4 gig CanaKit is like 99 bucks for the starter kit, an extra 20 bucks if you want to bump up to the 8 gig version of the Raspberry Pi. Beyond that, you will need some sort of keyboard and mouse. I'm just using one of these wireless. It's got a touchpad and keypad in one, but of course you can hook up a regular keyboard and mouse as well. You're also going to want some sort of monitor. In my case, I have this little 7-inch touchscreen monitor, but again, use whatever works. Any HDMI monitor will work fine for the initial setup of your Raspberry Pi. And then finally, you're going to need some sort of USB 3 hard drive, or even you could use like a flash drive, like a thumbstick, but you know, a thumbstick isn't going to be much more reliable than the microSD card we're replacing anyways. So I would recommend going for something like an SSD. This is a Seagate 2 terabyte external SSD, or something like an M.2 drive. And in this case, I just have like a super cheap 128 gig ADATA M.2 SSD. Note that this external enclosure, as well as this other one I'm about to show you, do not work with NVMEs. You have to have an actual M.2 drive, not an NVMe drive. So the final option that we have here is a really nice, elegant solution. This is the Argon 1 M.2 case. And what you get with this case is not only a really nice case for the Raspberry Pi that has an extension board that brings out the power, as well as, you know, 2 full-size HDMI ports on the back of the Argon 1, while still allowing access to your GPIO pins, but it has this extra sort of bottom piece that fits on here and has an M.2 slot in the bottom. So basically you put this case together, and then there's a USB 3 jumper that connects this bottom USB 3 port down to the USB 3 port on the M.2. This is a really nice solution. Unfortunately, the first USB jumper that I received with my Argon case was bad. So they're actually in the process of sending me a new one, but I was able to get this case to work just fine by using just a like 1-foot USB 3 to USB 3 jumper cable, if you will, or just small little USB 3 cable. So also this Argon 1 M.2 case is linked down below. Also, just a side note, if you have the original Argon 1 case that doesn't have the M.2 portion, they do sell just this M.2 portion. I think it's about 20 bucks, and then you can sort of upgrade your standard Argon 1 case to the Argon 1 M.2 by just adding on this extra little piece. Okay, so that's all the hardware that we need. The next step is we are going to flash the microSD card with Rasbian, and then that will allow us to initially boot the Raspberry Pi, and then we can go from there. If you purchased a CanaKit for this project, the CanaKit already comes with a microSD card that has Rasbian pre-installed onto it. So you can actually skip this step. But if you just have a blank microSD card or one that you're going to use for this project that has been used before, you want to first take your microSD card, plug it into your computer, and then the easiest way to get Raspberry Pi onto the microSD card is to use the Raspberry Pi Imager. There is an accompanying blog post for these instructions. If you want to follow along the blog post, which goes, step by step along with this video, There's a link for where you can get the Raspberry Pi Imager in that blog post, and the Raspberry Pi Imager is available for Windows, Mac OS, as well as Ubuntu. So once you have the Raspberry Pi Imager installed, you just want to choose which operating system you want to use. In our case, we're just going to use Rasbian OS 32-bit, and then you need to choose your SD card. In my case, I'm using this multi-reader 3 USB device. It's my 32 gig card. Make sure, double and triple check that you are selecting the correct card to overwrite, because once this is done, anything on that card is completely blown away. And if you had old pictures of grandma on there or something, you don't want to lose those. Okay, so you've been warned. All right, now that we have selected our OS and selected the card, we are going to click Write and Yes. While our microSD card is writing, we're going to get our Raspberry Pi ready to go. So the first thing you want to do is plug in your keyboard and mouse. In my case, it's just a single USB dongle here that is connected to this keyboard and touchpad right here. And then we're going to plug in one of our HDMI ports and connect that to this monitor right over here. We're also going to need some power, so let's go ahead and plug our power in. And then with the CanaKit, you get this nice little switch, so you can turn it on and off, which really helps it, so you don't have to continuously, pull the power out of this little power plug here. And then let's finally plug in our USB drive. You don't have to do the USB drive right away. We're not going to be messing with it for a little while, but you may as well plug it in for now anyways, and it won't really change these instructions at all. All right, now out of the corner of my eye, I saw that the microSD card had finished, so I now have Rasbian. We're going to plug the microSD card into the bottom of the Raspberry Pi, and then let's go ahead and fire it up. And we can see it doing its thing. It's going to resize the microSD card and then reboot. And there we go. Now you can see we have booted into Rasbian and we have the initial wizard here. All right, once the Pi is booted up, we're just going to go through the initial wizard here real quick. Then we're going to enable both VNC and SSH so that we can get to the Pi a lot easier. So here we go. We're going to say next. We're going to set our location information and time zone. Then we're going to change the default password for the Pi user. Set up the screen. Basically, if you have a black border around the edges of your monitor, you're going to want to check this box and say next. And then we're going to connect it to a wireless network. Now here, when it asks to update software, I always skip this part because I do updates manually myself. Again, you can choose to skip this or go ahead and run the updates. For the purposes of this tutorial, we're going to skip this. And then we're going to say restart. Once you've rebooted, we want to go over here to the Raspberry Pi icon, and we want to choose Preferences, Raspberry Pi Configuration. Then we want to click on Interfaces and set SSH and VNC to enable. And then click OK. Now we should have VNC and SSH set up. Let's go ahead and try that. First, I'm going to get my IP address. I'm going to do Control-Alt-T to bring up a terminal. And then we're going to say IPA. And we can see the IP address is 192.168.200.186. All right, so I have connected in on SSH. And let's try VNC as well. Now the resolution, the way that I have this recording, is so big. I'm actually going to shut down my Pi and then connect up that little monitor and then reconnect to VNC, just so that it's a little bit easier for you guys to see for this video. But this is not something that you're going to have to do if you're just following along with the tutorial. Okay, now we have our desktop down to a more reasonable size. And let's take a look at what we have as far as hard drives. So to take a look at the drives that are connected, we're going to say sudo fdisk-l as in list. And what I can see here is two things. We have disk/dev/mmcblk0. That's a 30 gig drive. That is going to be my micro SD card. And then we have disk dev/sda, which is 1.8 terabytes. That is my 2 terabyte SSD. But one thing that is sticking out to me right now is that this drive is already partitioned, right? I've been testing with it. I've been installing Raspberry Pis on this hard drive. So I want to first get rid of these partitions because I can't copy from the micro SD card to a drive that's already been partitioned. Now, if you have a brand new hard drive or a brand new M.2, you're not going to have to do this step. But since we have to partition this thing, let's go ahead and take the extra step of installing gparted. So click the Raspberry icon, come down here to Preferences, Add Remove Software. And we want to search for gparted. And here we go, Gnome Partition Editor. We're going to check the box and say OK. And then it's going to install that package. Now, if we click on the Raspberry icon again, we have System Tools gparted. Let's go ahead and click on that and authenticate. And here we can see our drive. So this is the SD card. And then if we pull it down, we've got dev SDA, which is my 2 terabyte SSD. And basically, I just want to click on these partitions and right-click, unmount, and then right-click, delete. Same thing with this boot partition here. Right-click, unmount, and right-click, delete. Now I have an unallocated, non-partitioned hard drive. By the way, before you apply any of these changes, make sure there's nothing on that hard drive you need to save, because this is going to completely wipe it away. We're going to click the checkbox to apply those changes. And close out gparted. Now, the next step is to copy everything that's on the microSD card over to the SSD hard drive. So we want to do basically a drive copy from one place to the other. So we're going to click on the Raspberry Pi icon. We're going to go to Accessories, SD Card Copier. Copy from device, we're going to say our microSD. And copy to device, we're going to say our Seagate 2 terabyte hard drive, and we're going to say Start. And of course, this will erase everything on the Seagate drive, so we're going to say yes. All right, after a minute or two, you're going to see copy complete, so we can just say OK. And close out the SD card copier. So since we've now copied the SD card over to the SSD, I'm going to say sudo fdisk-l one more time. And if you didn't have partitions before, you should have partitions now, and it should look very similar to this. You should have a dev SDA and a dev SDA2. One of the things that I forgot to do before we did the SD card copy was update Raspberry Pi and all of its packages. But since I just copied to the SSD, we're going to hold off on that. I will do the updates after I boot to the SSD, because if I did them on the microSD card, it's not going to matter anyways. We just copied everything over to the SSD. It wouldn't have those updates then when I booted into the SSD. Okay, but what we do want to do is take a quick benchmark of the speed of the microSD card. So, quick disclaimer here. No matter how I benchmark this thing, people on YouTube will tell me that I did it wrong. Okay, so this is not going to be an in-depth tutorial about how to properly benchmark a hard drive or a microSD card, read, write, cache, whatever. Throw all that out the window, right? We're just going to do a quick, let's take a quick benchmark that will show us some data that we can compare the before and after. Okay, so all of that being said, we're going to install a little package called hdparm. So we want to do sudo apt update, and then we're going to say sudo apt install hdparm-y. So now we can run sudo hdparm-t and then on the target drive, which is /dev/mmcblk0. That is our microSD card. And in a moment here, we should see right there. So disk reads 44.5 megabytes per second. Okay, so that's what our read speed is. That's what hdparm is showing as our read speed from the microSD card. The last thing that we want to do before we try booting to our SSD is we want to double check that USB is an option for booting, right? So we're going to say sudo raspi-config. And we want to come down here to boot options. Now, if you are running the latest and greatest version of the raspi-config program, this boot options is actually going to be under advanced. Okay, so remember earlier I forgot to do my updates? Well, had I done my updates, this setting will have moved. So it's good that I didn't do the updates because I'm kind of showing you both ways, right? We have boot options where I can click enter, And then we have boot order under boot options. So we're going to look at that. And we have USB boot is selected as sort of the default option. So we're just going to say OK. And it gave us an error. So look at that. So we're learning, right? This is always a learning process. So forget everything that I said earlier. We're going to have to update the device first before we do anything else. So let's go ahead and run the updates now. And actually, it'll give us a good learning opportunity to go back in, run the updates, and then reflash the card. Look, I'm doing this on the fly here, guys. So sometimes we make mistakes. Okay, so let's go ahead and do sudo apt update one more time. And then we're going to say sudo apt upgrade -y. And this upgrade process is going to take about 5 to 10 minutes. Okay, just a little sidetrack, but we are back up to date now, and we can check to see if our Raspberry Pi is supposed to be booting from USB if it detects that there's no microSD card installed. So to do that, we're going to do sudo raspi-config. Now notice the boot option, number 3, is now interface option. So these menu items have changed with the latest version. So we're going to come down here to advanced options. Now we're going to choose boot order, and we want to select USB boot and hit enter. And it says USB device is default boot device. We say OK, and then we select finish. And would you like to reboot now? We're not going to reboot right now because we want to do a shutdown instead of a reboot. So we're going to say no, and then we're going to say to shut it down gracefully so that it won't restart back up, we're going to say sudo shutdown-h now. It's shutting down. We are going to remove the microSD card and then power it back on. And I got my little 7-inch display here, which I can keep an eye on. Basically what we're going to see is it's going to try to find the microSD card. It's going to time out after about 20 seconds, and then it should boot right into the USB connected SSD drive. Hey, look at that. There we go. I just got the Raspberry Pi desktop. So now let's see if I can get back in with SSH. There we go. And then in the background, I saw that VNC also popped right back on. It was able to reconnect. So we are now in on the SSD. So that is just wonderful. Let's bring up, let's check a Fdisk again. So we're going to say sudo fdisk-l. And now notice that we don't have the other drive anymore, right? So the SD card is now missing because it's right here. I took it out of the Raspberry Pi. So now all we have is the SSD connected to USB 3 as our primary boot device. All right, so now let's go ahead and take our benchmark once again. So we're going to say sudo hdparm-t/dev/sda this time, right? We're not going to do the microSD. We want to do -sda. Command not found. Now, why is command not found? Well, remember, I copied everything over to the SSD, then I ran updates and installed hdparm. So we actually need to do both of those again on the SSD. If you follow along in the blog post, I promise you this is all in the correct order. Sorry if I confused anyone that's out there. So we're going to say sudo apt install hdparm. And yes. And now we can say sudo hdparm-t/dev/sda. And there we go. We get 108 megabytes per second. So more than double the speed of the micro SD card. The next thing that I'm going to do is I'm going to shut this down and I'm going to connect up the M.2 instead. And then we're going to benchmark that as well. Okay, booted back into the Raspberry Pi. Now that M.2 drive was one that I had already been testing with, so that's why it already had Rasbian installed onto it. Obviously, if you have your own M.2, you have to go through all these instructions again to get the operating system installed. All right, so let's take a look at Fdisk first. Sudo fdisk-l. In this case, we can see that dev SDA is a 119.2 gigabyte drive. It's actually 128 gig M.2. So we're going to say sudo hdparm-t/dev/sda. And this time we get timing buffer disk reads 347 megabytes per second. So remember, microSD card was about 44 megabytes per second. SSD connected to USB was about 108 or 110 megabytes per second. And the M.2 is 347 megabytes per second, or 3 times faster than the SSD. Which again is another compelling reason that you might want this Argon 1 M.2 case with the M.2 drive built right into the bottom. You can get some blazing fast speeds once you have actually gone through this process and you are booting from that M.2. Alright, so there you have it. Super simple to do. Links down below if you guys are interested in following along with that blog post or purchasing any of this equipment. If you enjoyed this video, make sure you give me a thumbs up, and if you'd like to see more videos like this, please click subscribe. My name's Chris, the Crosstalk Solutions, and thank you so much for watching.